Welcome back. Now we're going to look at the Descartes rule of sign changes for upper and lower bounds. This is another nice tool that kind of lets us know what are possible zeros, or what are ways we can limit the number of zeros we have to check when we're trying to find all of them for a higher degree function. What it says is that given any real polynomial equation, p of x equals 0. So the only important thing is you got to make sure it's set equal to 0. The number of positive real zeros is equal to the number of variations or sign changes in the sign for p of x, or an even number less. Even number less just means whatever our original number of variations is. I don't know, let's say like 10. Even number less than that would be 8, 6, 4. If we started at 9, it would then be 7, 5, 3. You're just subtracting by 2 every time. The number of negative real zeros is equal to the number of variations in sign for, instead of p of x, we're going to look at p of negative x, or an even number less. So for example, if we were to say p of x equals 3x to the fourth plus 4x cubed minus 3x squared plus 2x minus 1. When we look at this equation, we see how many times is it going to change sign. We go from positive to positive, no variation. Positive to negative, 1 variation. Negative to positive, 2 variations. Positive to negative, that's 3 variations. Which means there's a possibility of 3 positive zeros. Or a number even, number less, so subtract 2, 1 positive 0. Those are just possibilities. There's no guarantee that it's either one of those right away, but we know those are what our possibilities are. When we take a look at p of negative x, we get 3x to the fourth minus 4x cubed minus 3x squared minus 2x minus 1. So when we count how many variations are, positive, negative, there's 1, negative, 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 there's only 1 variation, which means there's 1 negative 0. Again, this helps limit, especially when we're using the rational zeros test, and we get this huge list of positive, negative, positive, negative, positive, negative numbers. If we can limit those by saying, hey, we know we've only got 1 or 2 positives. If we say we've only got 1 positive and we've already know what it is, we can examine only negative numbers to help us limit our search. Something else that'd be good to know is our figuring out what our upper and lower bounds. What it says is that given p of x is a polynomial with real coefficients, if p of x is divided by some factor x of b, as long as b is greater than 0, it's a positive number, using synthetic division, and the coefficients in the quotient row are either positive or 0, then b is an upper bound of the zeros of p. For example, if we were to take the function x to the fourth plus 3x squared minus 2x plus 5 and divide it by x minus 2, we use synthetic division, say 1, 0, 3, negative 2, 5, put our 2 out front, 1, 2, 2, 4, 7, 14, 12, 24, 29. Because all of these are positives or zeros, we know that x minus 2, and specifically 2, is the upper bound for all of our zeros, which means every zero we have for this function has to be less than 2. We can do a similar process to figure out what our lower bounds are. What we're going to say is that p of x divided by a, where a is less than 0, using the synthetic division, and all the coefficients in the quotient row are alternating between positives and negative, then a is the lower bound on the zeros of p. So for example, let's say if we were to take x cubed plus 9x minus 5 and divide it by x plus 10. That means we're going to do synthetic division with negative 10, have 1, this should be x squared, 1 9, negative 5. Bring down our 1, negative 10. Add those together to get negative 1. Multiply to 10. Add those together to get 5. Because these alternate from positive to negative, back to positive, when that pattern happens, positive, negative, that means that negative 10 is a lower bound on all of our zeros, which means all of our zeros will be greater than negative 10.